In the soft glow of an isolated lab, a detector clicks. Inside, the friend writes photon detected. A fact has been born. Local, definite, archived in ink and memory. But now, step back. To Wigner, standing outside with his interferometer and extreme patience, the whole room, friend, detector, notebook, and air, can be treated as a single quantum object. If none of those inner records have leaked to the world, no whisper of the outcome has slipped under the door as heat, light, or sound, then in principle, Wigner can test whether the entire room still carries quantum coherence. As if the friend's measurement never quite settled. 2 descriptions. Inside, I saw the click. Outside, I could in principle reveal interference from the whole. Which is the real story? The subtle answer is about records. If the friend's note or her brain state has entangled with the environment, if air molecules, scattered photons, or even gentle vibrations have broadcast her result, then Wigner's interference test will fail. Decoherence has already written the outcome into the world's margins. If, however, the room is so perfectly isolated that no trace has escaped, then Wigner's grand test may succeed, showing that from his vantage, no final fact existed yet. No paradox arises when we respect what each observer can actually access. The friend's fact is a fact for her, given her records. Wigner's experiment asks a different question of a larger system and can, in principle, get a different kind of answer. Only when the 2 compared notes literally bring their records together must the stories dovetail. At that moment, the broader world gains the same page. Modern laboratories have inched toward this thought experiment with entangled photons, superconducting circuits, and tiny quantum memories that stand in for a friend. Each confirms the same lesson. Facts live where records live. In short, a result can be definite for one observer and not yet for another. Consensus arrives when records meet. Here is a favorite riddle. Decide after a photon hits the screen whether it behaved like a wave or a particle. Surely that flirts with rewriting the past. We send photons toward 2 slits. If we leave them untagged, their arrivals form an interference pattern, ripples of light and dark that speak of superposed paths. If we tag the paths red for left, blue for right, the pattern collapses into 2 simple mounds. No interference. Now the twist. We route each photon's partner through a device that either reads those color tags or erases them. And we make that choice late, sometimes after the first photon has already landed. When we later sort the first photon's positions into piles based on what we did to its partner, something uncanny appears. The pile corresponding to tags erased shows interference. The pile corresponding to tags read does not. Did our late choice reach backward in time to change what the earlier photon really did? Nope. If you ignore the partner entirely and look only at the main screen, you never see interference, just a smooth haze. The interference appears only when you condition on the later information and sort the data accordingly. No signal travels to the past, no message outruns light. We are not rewriting history. We are rewriting which story is consistent with the records we agree to keep. In Wheeler's delayed choice spirit, quantum behavior isn't a costume sewn at birth. Wave-like or particle-like, it is a verdict delivered by the kind of question we finally ask, by which records we choose to preserve or erase. What it all boils down to is that late choices don't change earlier events. They change how we slice the data, and therefore which pattern our records reveal. Bell's theorem tests whether distant particles carry hidden, pre-agreed answers. The Leggett Garg program asks a simpler, more intimate question. Does a single system carry a trajectory-like property at all times? A definite value you could, in principle, read without disturbing it? If such macro realism holds, if things really do have pre-existing states, plus a way to peek non-invasively, then certain combinations of time-separated measurements must obey tidy bounds? Experiments with superconducting qubits, nuclear spins, photons, and mechanical oscillators keep breaking those bounds. Even when engineers use clever, negative result, or weak measurement tricks to disturb as little as possible, the data say no. The world does not, in general. come with all answers written in the margins, waiting patiently for us to lift the page. This is not a license for chaos. It is a reminder that values in quantum land are not simply there like ink on a ledger. They are coaxed into being by the context we create, by which questions we ask, and when, and how gently. Fundamentally, for single systems across time, nature resists the comfort of pre-inscribed trajectories. What exists to be read depends on how and when we try to read it. Suppose you believe that every measurable property of a system has a definite value, independent of how you choose to examine it. The Kochen Specker theorems turn that belief into a logic puzzle. Find you cannot complete it without breaking your own rules. In everyday terms, the outcome you get can depend on which compatible questions you ask alongside it. It's not because the system is coy, but because the quantum fabric links answers together in ways no list of hidden entries can satisfy all at once. Change the context, and the web of relationships you probe changes as well. This contextuality is not just a philosopher's flourish. It has teeth. Experiments across platforms validate it. And theorists now count contextuality as a resource fuel for certain quantum computations that outpace classical rivals. The puzzle that forbids a universal context-free ledger turns out to power the very advantages engineers seek. Basically, in quantum mechanics, outcomes belong to contexts, not to a secret context-independent checklist. Wigner's friend tells us that facts are local to records until records are compared. The delayed choice eraser teaches that we do not rewrite events. Only the story our kept records can consistently support. Leggett Garg shows that single systems do not carry a full script through time, ready for non-invasive reading. Contextuality reminds us that answers are braided to the questions we pose. Hold these together, and a sturdier picture emerges. Quantum theory does not license retrocausality, nor does it require a human soul to perform a mystical act. It says something more grounded, and perhaps more wondrous. Records make reality shareable. Before records meet, different observers can quite legitimately live on different pages. When records meet, single edition goes to print. But printing an edition, amplifying a click, copying it, storing it, protecting it, is not free. It takes work. It writes heat. It explains why facts resist erasure and why time's arrow feels so firm. In simple terms, measurement doesn't rewrite the past. It rewrites which past is consistent with the records we allow into the story. In the next part, we follow the cost of knowing. From Maxwell's demon to the warmth of data centers. We'll see why every observation spends a little entropy to make a fact, and why the universe's ledger of records points inexorably forward.